Hello friends, welcome back to my YouTube channel. This is Ramdas Pandit Bhasan, working as Assistant Professor in Chemistry at Maratha Vidya Prasarak Samaj, Nasik. In this video lecture, we are going to discuss about the relation between molar solubility and solubility product of some common sparingly soluble salts are there. So we can see here types AB, AB2 or A2B, AB3, A2, B2, A2, B3, etc. So like this sparingly soluble salt, we have to say their relationship between molar solubility and solubility product. First of all, we have to consider the sparingly soluble salt of type first A B. Okay, so you will see the reaction for the type AB, that will be in a any kind of substance in a soluble state, a saturated solution. So after dissociation of that substance, okay, that salt, you will get two ions, A plus aqueous form plus B minus. Again you will see that is aqueous form. The solubility product equation by the law, so that is ASP, okay, solubility product is equals to in bracket A plus into in bracket B minus. So the meaning of bracket, we have know the concentration of this space is A and the concentration of space is B, right? Now this is the molar solubility, okay, of salt is S. Then in bracket A plus is equals to S and in bracket B minus is equals to S. So the concentration for the first species, we can consider the molar solubility, that is S, okay, and for the second species also S. So we can write in this way: ASP is equals to concentration of A plus into concentration of B minus is equals to S into S, that is the S square. So the solubility of salt, that is S, and under root of capital K SP, okay, we can denote that solubility salt for the type A, okay, type first AB. Now we have to see the second type of salt, that is AB2, okay, or we call them A2B, okay. So you will see the dissociation for this type of salt. You will see A2 plus in aqueous form plus 2B minus. If you will take A2 molecules and B1, so what you will get here will be 2A, okay, and here will be 1B. So in this way you have to dissociate, okay. So the solubility product by the equation, you will see KSP is equals to in bracket A2 plus into in bracket B minus 2 or a square. So let us, the molar solubility of salt is the S, then in bracket A2 plus is equals to S and in bracket B minus is equals to 2S. So here with the bracket square, so we can consider 2, okay. Here is the only one space, so we can consider 1 S. So the KSP is equals to in bracket A2 plus into in bracket B minus bracket square. So you will write in this way: S into in bracket 2S bracket square is equals to 4S cube. So the solubility of salt for this type of salt, okay, S is equals to thrice under root of Ksp divided by 4. This is for the type second, that is AB2, right, or A2B. Now we have to see for the third type of salt. It will be the AB3. Okay. You will consider A3B also. So you will see the dissociation for the AB3 molecules. A3 plus in aqueous form plus 3B minus. Again you will see the aqueous. And solubility product equation by the law. So Ksp is equals to in bracket A3 plus, okay, into in bracket B minus Q, okay, bracket Q. So this molar solubility of salt is yes, okay. So then in bracket A3 plus is equals to yes, and in bracket B minus is equals to thrice yes. You will see the number are increasing here, so number of yes will be increases here, okay. So in this way you will get the Ksp is equals to in bracket A3 plus in bracket B minus cube is equals to yes into in bracket 3s bracket square is equals to, you will calculate, so you will get 27 yes raised to 4, okay. So in this way you will see the solubility of salt for these kind of molecules, okay. Third type of salt AB3, that is 4 under root of Ksp divided by 27. Now we have to see for the next salt, it will be the A2B2, right. Now you will see the dissociation for these molecules for this salt, 2A plus, okay, and 2B minus, all they are in aqueous form. For the solubility product by the equation, you will see the Ksp, so here will be the 2A and 2B, so you will write here bracket square for the both species in this way. Molar solubility of salt is yes, then in bracket A2 plus is equals to 2s, okay, and in bracket B minus is equals to 2s. So the Ksp will be in bracket A minus bracket square, right, and in bracket B minus bracket square is equals to in bracket 2s bracket square into in bracket 2s bracket square. So in this way you will calculate, so you will get 16s raised to 4. So the solubility of salt for this kind of molecules you will get that much, right, 4 under root of Ksp divided by 16, right. Now we have to see for the next molecules, it will be the A2B3, okay. You will see the dissociation for these molecules, that is 2A3 plus in aqueous form plus 3B2 minus aqueous form. So the solubility product equation by the law Ksp is equals to in bracket A3 plus bracket complete square, right, in bracket B2 minus bracket cube. So the molar solubility of salt is yes, then you will see in bracket A3 plus is equals to 2s, and in bracket B2 minus is equals to 3. So the Ksp will be in bracket A cube plus square, and in bracket B2 minus bracket cube is equals to in bracket 2s square plus 3s square is equals to, you will get 108s raised to 5. So the solubility of salt for this kind of molecule. Now we have to see the examples based on solubility product, right? So the example you will see here, the solubility product of silver chloride in water is 1.56 into 10 raised to minus 10. To calculate its solubility in water at 25 degrees Celsius in a gram per liter, and given atomic weights of silver, that is 108, and for the chlorine 35.5. So that we have to calculate the solubility product of silver chloride, right? Now atomic weight is given for the two elements, silver and chlorine. So the KSP, right? That formula we can use for the calculation of solubility product, that is in bracket Ag plus into in bracket Cl minus is equals to S into S is equals to S square. So the solubility of salt is S is equals to under root of KSP. So we have no KSP, right? Solubility for the this kind of salt, silver chloride, this is the one of the salt. So KSP is given, so you can directly put this value and you will get this much. Okay, 1.25 into 10 raised to minus 5, so you will get this value. And the solubility of the silver chloride in gram per liter, so we have to take this formula, solubility into molecular weight, right? So molecular weight we have no, so we have to put this value. Okay, molecular weight, right? We have to add both values and you will take here. Okay, molecular weight of this whole substance silver chloride and solubility KSP, that is we have calculated, so you will write here, and after calculation you will get the solubility for this silver chloride 0.00179 gram per liter. So in this way we can calculate easily solubility of different kinds of molecules, okay, with the help of KSP and with the help of molecular weight. Now we are going to see the next topic, that is the applications of solubility product principle, and they are, you can see the first one is determination of the solubility sparingly soluble salt, and the next is the predict the precipitation reaction, and third is differential precipitation of an insoluble salt, and the fourth one is precipitation of soluble salt, and last one is inorganic qualitative analysis, right? So total 5 applications are there, so we are going to see in detail it, right? In that the first one is determination of solubility sparingly soluble salt. Okay, so in this case if you will take the silver chloride, okay, into the water, so what will you will get two ions Ag plus plus Cl minus, okay, cations and anions, and you will see the solubility product of silver chloride is related to the solubility by the relation, right? So you will see the relation here, KSP is equals to in bracket Ag plus in bracket Cl minus is equals to S into S is equals to S square. So S is stands for the solubility of AgCl in a solution, right? And the solubility of salt, that is S, okay, small s. So you will write under root of KSP mole per liter. So in this way we can determine the solubility of sparingly soluble any kind of salt, right? This is the first application for the solubility product, right? Now we are going to see the second application, that is predict the precipitation reaction. Okay, so with the help of any kind of substance, it will be precipitated or not, we can determine. Okay, so before that we should know what is the ionic product for this kind of things. So the ionic product is the product of concentration of ions present in the actual solution is called ionic product. Now if you will see in the water, if the ionic product, right, ionic product of the salt solution is greater than solubility product, so that the supersaturated solution will get and precipitation will take place is there. Okay, see here in the water, if the ionic product of salt solution is greater, okay, than solubility product, so the supersaturated solution you will get and the precipitation will takes place. But if in ionic product of salt is less than solubility product, so there will be the unsaturated solution you will get and there is no precipitation is there. Okay, there is no precipitation takes place is there. And if the ionic product of salt solution is equal to the solubility product, so there will be the saturated solution. Okay, there is a equal proportion, that's why you will get the saturated solution, but also there is no precipitation takes place of this solution, right? So in this way you will determine the precipitation of this solution. Just we have to decrease the proportion of ionic product of the salt and solubility product. Okay, so you will get the supersaturated solution, unsaturated solution and saturated. Okay, that means you will automatically get the precipitation or without precipitation is solution. All right, now we have to see the third application, that is differential precipitation of an insoluble salt. Now in this application, if we want to estimate the halides from the mixtures of halides, okay, it may be iodine, it may be chlorine, it may be bromine. So first of all, which one you will get in precipitate form and what are the values? Okay, so if you will take the AgNO3, okay, titrate with a mixture of halides, okay, so you will get different kinds of precipitate. Okay, first of all it will form AgI precipitation. Okay, first preference we will go to the AgI precipitate formation, okay, because of the solubility product. Okay, and the second preference will go the AgBr, right, and the third one will go the AgCl. So like this precipitate will form if you will the AgNO3 will with titrate with the halides mixture. Okay, after that you will estimate the halides, right? So the solubility product values of the silver halides will be for the AgI, that is 9.4 into 10 raised to minus 17, right? And for the second AgBr 7.7 into 10 raised to minus 30, and for the last AgCl 1.56 into 10 raised to minus 10. So all they are solubility products values of silver halides. Now fourth application we have to see, that is inorganic qualitative analysis, and we have know this because of we have performed this, right, in the experiment. So it is used to precipitation of sulfides and hydroxide, particularly for the estimation of basic radicals in inorganic chemistry. So with the help of solubility product we can estimate the basic radicals in the inorganic chemistry. We can simply in this way. Okay, now we have to see the last application, that is precipitation of soluble salt. In that the first one is purification of common salt, right? So in this case you will see the natural common salt, that is NaCl, consists of many insoluble and soluble impurities. We have no NaCl is present in ocean, right? So in that, number of impurities present is there, that will be the insoluble and soluble. And saturated solution of common salt is prepared and insoluble impurities are filtered out from this. Okay, so that's why we get the pure salt, right? So to remove the soluble impurities from the aqueous solution of common salt, okay, how we can filter out it? The HCl gas is passed into that solution. After that, the concentration of chloride ions increases in solution due to the ionization of HCl. Okay, after passing the HCl gas, there will be the ionization process, right? And the chloride ions will be increases, right? And the ionic product of this Na plus and Cl minus ions exceeds, and the solubility product and pure sodium chloride precipitate out from the solution. Like this, you will filter out the, or you will say the purification of common salt, that is NaCl. And in this application, one more is given, salting out of soap, right? So the solution soap is precipitated by the addition of concentrated solution of sodium chloride. So by the addition of NaCl, concentration of Na plus ions increases. That's why the ionic product of these ions and Na plus ions exceeding the solubility product, and therefore the soap precipitate out from this solution. By addition of NaCl, there will be the concentration of this Na plus ions will be increases, okay, and steric will be, ionic product of steric also increases. So that's why you will get the precipitation of this soap and you will separate out from this particular compound. So in this way, we have seen the application for the solubility product, right? We have to remember this.